Hi, it's me, Paula, the math tutor. In this video, we're going to talk about probability mass functions. What we're gonna do is first define what a probability mass function is, what we mean with that, and we are going to set the conditions for a function to be a probability mass function. And then we are going to see some examples. So if we have a discrete random variable, we can create a function that describes the probability distribution of this variable. We are going to define the function p of x as the function that gives you the results of the probabilities for each of the possible outcomes, for each of the possible values of the discrete random variable capital X. The domain of this function is going to be the set of possible outcomes, the set of the values of the discrete random variable. And the range of the function is going to be the numbers in the probability distribution. What this function does is it grabs the outcome, it grabs the result of x, and it gives you the probability for x happening. So we are creating a function that gives us the result of the probability if we start with the outcome for x. Let's see an example of this. Let's say you have this function. P of x equals x squared plus 1 divided by 34. The domain of this function is 1, 2, 3, and 4. We want to see if this function is a valid probability mass function. What we want to see is that the results of p of x are actually a valid probability distribution. We know that in a probability distribution, first of all, the numbers need to be between 0 and 1, meaning that the results for this function need to be something between 0 and 1. Let's calculate. For 1, the result is 2 over 34, for 2 is 5 over 34, for 3 is 10 over 34, and for 4 is 17 over 34. So we are okay. They are between 0 and 1. The other condition is that if we add all of them, the result is going to be 1. Let's see. 2 over 34 plus 5 over 34 plus 10 over 34 plus 17 over 34 is actually 34 over 34. So it's 1, meaning that the range of this function is a valid probability distribution. So this could be a probability mass function for a random variable. Let's put this in action. In this example, a policeman is inspecting the safety of tires of cars passing through a checkpoint. We are going to represent with capital X the number of tires this policeman sees that need to be replaced. And we have this table to represent the probability distribution of the variable. With 0 tires to be replaced, we have 0.68, meaning that 68% of the cars that passed through this checkpoint don't need a tire replaced. For 1, we have 0.2, for 2, we have 0.06, for 3, we have k, a number we don't know, and for 4, we have 0.02, meaning that there are 2% of the cars in this checkpoint that need all 4 tires replaced. And the first question in this exercise is find the value of k. We need to think of a way of finding that value of k, so what we get from this distribution is actually a probability distribution. So if we consider the probability mass function, it holds the condition we just discussed. And we know that the sum of all these probabilities need to be 1. So what we can do is we can add 0.68 plus 0.2 plus 0.06 plus k plus 0.02 and make it equal to 1. And now we have an equation we can solve. In this case, we know that k is going to be 1 minus 0.96, so k equals 0.04. If we go back to the context of the question, this means that the probability of a car needing 3 tires replaced is 0.04. 4% of the cars that passed through that checkpoint need 3 of the tires replaced. thing. Let's say they ask us to find the mode of the distribution. Luckily for these cars, the one that with the highest probability is 0. Now, let's say we want to find the probability of x being larger than 1. Again, in context, we want the probability of a car needing more than one tire replaced. Because this is a discrete variable and we can assume that the results are independent, that one car needing a tire replaced is independent of another car needing a tire replaced, we can just add the probabilities that are larger than 1. So we could add the probability of x being equal to 2 plus the probability of x being equal to 3 plus the probability of x being equal to 4. And this is going to give us 0.12. This means that 12% of the cars that went through this checkpoint need more than one tire replaced. And this is it for this video. In the next one, we are going to introduce a new concept, the concept of expected value. Bye bye!